3 years ago, I made this video simulating my Warman 2020 competition robot. However, because of COVID, we didn't get to actually build and test our designs. However, the following summer, our lecturer for the subject, Iad, the absolute legend, allowed some of us the chance to build our designs and challenge two other South Australian unis, Flinders and UniSA. So in February 2021, my partner Josh and I had 1 week to build the robot. This is how it went. Firstly, the challenge rules. A PDF of the full set of rules and challenger outline is in the description. But to summarise, the robot has to start behind the start line, the robot has to finish behind the start line, the robot has to start within the dimensions 500 by 500 by 500 millimeters. The robot shall not exceed 6 kilograms, and the primary objective of the robot is to drop 1 ball into tube A, 2 into tube B, 3 into tube C, and 4 balls into tube D. Scoring will be based on the following formula. The score is equal to the deposits into tubes A, B, C, and D multiplied by 10 plus the return score plus 120 minus the runtime in seconds multiplied by 0.5. Now the boring stuff's out the way, let's get started. The base. We started with the main feature of the robot, which were the unique helical wheels. They were designed this way to traverse the square steel bar on the challenge board. I was really proud of this design as it was simple and elegant and traversing the main obstacle. The next step was getting the electronics working to move the robot back and forth and the servo arm to drop the ball delivery arms. We then assembled the wheel and electronics onto a board to form a base. And the first test didn't go too well. We carried on and managed to make some progress and eventually got it running quite well. We noticed the 3D printed surface liked to slip, so we put some rubber matting used for kitchen utensils to help it grip better. After a few tests, we were confident it could move along the board and over the obstacle. Fixed arms. Next we built the ball holders for the first 2 tubes, which drops 1 ball into tube A and 2 into tube B. They were made from PVC pipe with sheet metal for a simple gate mechanism. Swinging arms. The swinging arms drop 4 and 3 balls into their corresponding tubes D and C. They were created in the same way as the fixed arms, but with a pivot point built in to let them swing into position. They were coupled together mechanically and held in place with a single servo, which when released allowed both arms to swing under their own gravity. After this assembly, the main structure was completed, with the rest of the robot body assembled with scrap wood, glue and screws. Testing. After the main assembly was complete, we tested the robot repeatedly to fine-tune the code and function. The night before the competition, the robot wouldn't move as one stepper motor wasn't strong enough. Despite buying 2 motors, one of the driver circuits died, so the only solution we could quickly come up with was to reduce the weight and keep using 1 motor. After drilling out a stupid amount of holes, the robot managed to move. Just. Competition day. Finally the day had come for our little bundle of hopes and dreams to shine. Each competing team was given 1 practice run, which didn't go as smoothly as it could, but it did meet all the rules for starting and finishing without disqualification. Now it was time for our scoring run. We were so excited that all our hard work paid off, and although not the fastest on the track, it was certainly slow and steady. Based on our run, here's the score breakdown we would have gotten. 1 point for deposit A, 2 points for deposit B, 3 points for deposit C, and 4 points for deposit D. Since our robot returned, we'd also earned the return score of 20 points. Including our run time of 114 seconds, our score was 123 points out of 180, which gives us about a 68% score of the maximum. However, 180 points is unattainable, as that would require a robot to complete the challenge in 0 seconds according to the formula. A more reasonable maximum score would be around 165 points, which would be a robot that only takes 30 seconds. Same. But that's just what I tell myself, so we seem to have a higher overall score. Despite its average performance, for what it was worth, it was still the winner of the friendly competition against the other South Australian unis, and it was a great opportunity to meet other students, see how they tackled the problem, and visit the Flinders Uni campus. Our robot clearly wasn't optimised for the track, but we were still happy with its achievements, given the extremely limited budget and time frame. The project taught us a lot about electronics, coding, the iterative engineering method, planning, testing, verification, and a lot of experience you can't read in a book. Hopefully this has offered some inspiration for the next generation of uni students undertaking the Warman competition, or at least provided you with a bit of entertainment. Thanks for watching, and cheers.